Contrary to deeply rooted beliefs, Polaris is not only visible on Fridays in the polar winter from the North Pole and its equated areas. It can be seen much further south, all the way to the equator, and even sometimes a little lower. And yet Polaris can easily be seen with the naked eye. There are two distinctive features that make it easy to find. The first is that there are no stars around Polaris that are brighter than it, so it's hard to confuse it with other nearby stars. Two, it is located almost exactly at the point in the sky where the North Celestial Pole is located. What's that? Well, it's simple. If you mentally extend the axis around which our planet revolves up into the sky, it will pass very close to Polaris. So, the Earth rotates on its axis once a day. For us, those people who live in the northern hemisphere of the Earth, it looks as if all the stars make one revolution around the Earth's axis of rotation once a day around the point where Polaris is located. Since Polaris is directly above the Earth's North Pole, its position in the sky clearly indicates the direction north for all observers. In the past, Polaris was always very important for navigating at sea or without a compass. Even today, you can use it as a reference point. For example, when hiking, it is easy to find even without much astronomical knowledge. How to find Polaris? All you need for this is to find the constellation of the Big Dipper. This cluster of stars is very prominent and famous, and to not find it, you have to try very hard. If you lengthen the line connecting the bright back stars of the bucket of the Big Dipper about 5 times, you will find yourself right at Polaris, and you'll instantly know where north is. Polaris has long served as a reliable indicator of the North Pole, but it wasn't always so. The fact is that the axis of rotation of the Earth gradually changes its direction. It describes a small circle in 26,000 years. But Polaris is interesting to us not only from a navigational point of view, it's also interesting from a purely astronomical point of view. How about this fact? For example, this space object is not really a space object at all. It's 3 objects, 2 stars forming a very close double star system. Polaris A is a big yellow giant star with a mass 4.5 times that of the Sun and a brightness about 2,000 times stronger. Its companion, Polaris AB, is a dwarf star. The distance between the objects is only about 20 astronomical units, which roughly corresponds to the distance between the Sun and Uranus. At a distance of 2,400 AU from the double system is the Sun-like star Polaris B. It orbits around both components of the double star system. The distance between the 3 stars of the Polaris system and Earth is 433 light-years. Today, it has been measured quite accurately thanks to satellite instruments. Not so long ago, though, it was thought that the distance was about 330 light-years. The problem in determining the distance was the lack of the right data about the nature of Polaris itself. It was originally thought to be a Type II Cepheid. The difference between the 2 groups of Cepheids lies in their origin. Classical Cepheids belong to the so-called population I, as the youngest generation of stars, which includes, incidentally, our Sun. Type II Cepheids belong to population II, an older generation of stars. Only population III stars, which formed just after the Big Bang, are older than them. Exactly how Cepheids changed their brightness is fairly well known. Polaris, however, turned out to be special. Until 1963, its brightness had changed by about 1/10 of a star magnitude in the history of observations. That is, about 5% of the total brightness. After 1966, however, this change slowed rapidly. It was only about 2.5%. Current observations show that the star is getting brighter again. This behavior is not typical for Cepheids of this type. Therefore, astronomers have decided that the close companion, Polaris AB, is somehow involved in this process. The change in brightness of the star is obviously caused by a change in its temperature, and here most likely can play a role in the movement of objects around each other. But so far, this is just a hypothesis. The case becomes even more interesting if we take into account the observations of ancient astronomers. If we compare the records of astronomer Ptolemy with today's, the brightness of Polaris, it turns out increased by 2.5 times. And if this is really true, this fact is quite intriguing, because such a change in brightness is simply inexplicable. The mystery associated with the changes in the brightness of Polaris is even more interesting if you consider that it used to be a kind of 0 point of the scale used to measure the brightness of stars. Before the Polaris variable was discovered, it was thought to be simply an ideal reference point, with a unique fixed position near the celestial pole, which, in addition, allows the brightness of all other stars to be measured relative to it. Therefore, Polaris will long be of interest to astronomers and ordinary citizens. The former will still try to unravel its strange properties. The latter will continue to use it as an aid to orientation in the dark. If it's clear tonight, go out on your front porch in the evening. Find Polaris. Feel like an ancient sailor who is sailing across an uncharted ocean to mysterious, unexplored lands. Thank you for watching this video to the end. Don't forget to like and subscribe to the channel to learn more about space.